Lately, we've been studying a lot about area of polygons. Well, we're going to go ahead and apply that knowledge today to find surface area. So take a look at example number 1 here on the paper. We're given a pentagonal prism, and you can remember that the name that you give a prism is denoted by the type of base it has. And the bases are those faces that are opposite of each other and that they match. So we have two congruent bases and they're both pentagons. So that's where we get the name of this prism. Alright, so to find the surface area, we're going to use the given information. So we have a side length on the pentagon that's 12 feet. We know that the height of the prism is 12 feet. And the apothem, going from the center of the pentagon to the side, is 8.3 feet. So we'll use all of that to calculate our base area, our lateral area, and then add those two together to find our total surface area. So here's our first step, base area, or you can call it BA for short. We have to find our perimeter first. So there's 12-foot sides on the pentagon and there's 5 sides. So we'll do 12 times 5 and find that the perimeter is 60 feet. Alright, we're already given our apothem, so now we have everything we need to find the area of one pentagon. The area equals 1/2 times the apothem times the perimeter. You just go ahead and substitute those values in. So there's the 8.3 substituted in, and there's the 60 substituted in. Multiply everything, and we get an area of 249 square feet. Here's a little times 2 because we have those two congruent bases. We want to make sure we get both of our bases areas. Multiply that and we get 498 square feet. So that's our total base area. Now we're ready to go on to lateral area. Our lateral faces are all squares in this case. They're 12 by 12 squares. So you can just multiply the length times the width, or you could square it if you want to, and you can get the area of 144. That's just one rectangle though, and we know that there's 5 congruent lateral faces on this figure. So we'll take that area and multiply it by 5, coming up with a complete lateral area of 720 square feet. Alright, last step. We take our base area and our lateral area and add them together. 498 plus 720 gives us a total surface area of 1,218 square feet. So what does that number represent? Remember, that represents how many square feet cover the complete outside of this figure. Alright, so that's surface area of a pentagonal prism. There's one more example down here to take a look at. This one, if you have the worksheet from in class, it was problem number 4. If not, that's fine. Here we are just looking at a cylinder. It has a base that's labeled with 8 inches going all the way across the bottom, and it goes through the center, so that's our diameter. Now, surface area of a cylinder has a nice, neat formula that maybe you guys have on a formula sheet. If you don't, it's right here in front of us, and you can look at the two different parts, the main parts in the formula, here and here. They actually describe how we find the base area and how we find the lateral area, kind of like example number 1. So the base area, if you look at the bases, there are 2 circles, right? So here we have doing the area of 2 times, how do we find the area of a circle? We do pi r squared, right? So there's the base area. And then our lateral area is 2 pi r times the height. Now that, if we had a net, we could stretch it out and see that that would be multiplying the dimensions, the height, times the length of a rectangle that would wrap around the outside of that cylinder. Anyways, now we have our formula and we know our values. Our radius would be 4 because that's half the diameter, and our height is 3. All we do is substitute those values in the spots into our equation, and then we solve it by multiplying here, multiplying there, and adding everything together. Or you could do all of this at once in a calculator if you'd like. 2 times pi times 4 squared plus 2 times pi times 4 times 3. You can use the pi symbol in your calculator if you want to be the most precise in your calculations. If you don't have a pi symbol on your calculator, you can use approximately 3.14, and you can still get a nice estimate, a pretty accurate answer on your surface area for that cylinder. So that is a little bit about surface area, and some things that you might want to think about are, well, what if I have an application problem that involves a cylinder just like this one, only it doesn't have a top on it? So maybe it's like an open can, and so you have to find the surface area of the outside but not the top. How would that change your formula? Something to think about. You can pause it for a minute while you're thinking and then push play again to compare what you're thinking to what you should be doing for your action. Okay, in that case, what you would do is not include the times 2 in our formula. So think about that. If we just have pi r squared, that just takes care of one of the circles instead of including both of them in the formula. So it's just a slight adjustment to our formula. So it's good to think about what the different parts of our equations mean and how we can manipulate them to use them in different ways. All right, thanks for learning about surface area with me today.